Hi, I'm Ross Trethewey, and welcome back to another episode of Ask This Old House. When most people think about solar, they think about photovoltaic panels or solar electric panels that takes the sun's energy and convert it into electricity. There's also solar thermal, which uses the sun's energy to create heat or hot water used for domestic hot water or pool heating. But today, we're headed to a homeowner's house to help them upgrade their water heater. And we're going to be using a new technology that pairs up heat pumps with solar thermal collectors. We're really excited to help them out. You must be JC.
Hi, Ross. Welcome to our home.
Yeah, we're glad to be here. You wrote in about a water heater upgrade and trying to get more efficient. So tell me about that.
So we use exclusively oil here. And because of that, our water heater is all electric and it's not very efficient.
Sure.
So I'd like to upgrade to a more efficient water heater if possible.
Right, so you got an oil system for space heating and you have a traditional electric water heater for domestic hot water.
That's correct.
Got it, okay. Well, I got a jump start on it and I reached out to a local company that specializes in energy efficient water heating options. He's gonna help us out today.
I think he's in the basement already. I can take you there and meet him.
All right, let's go.
Thank you.
Hey, Bruce. Good
Morning,
to see you.
Ross.
What's going on?
How are you?
All right, so do you get a lay of the land here about what's going on? I see the oil boiler, see
Yeah.
the electric water heater.
Yeah. So in this house, the space heating's by oil boiler, and the domestic hot water is by what we call a resistance water heater, just a regular electric tank. So there's an electric element in the top, there's an electric element in the bottom. This is the cold in from the street, and this is the hot out to the house.
Efficiency-wise, we're looking at...
So its efficiency is about 1 or a little bit less. So a unit of electricity goes in, you get a unit of hot water out, $1 in, $1 out.
Okay, so when you think about these, we think about upgrades and what can we do better? So what are
Right,
the other options out there?
Right, so the hybrid water heaters, everybody's installing heat pumps. As a matter of fact, in 2029, you're not gonna be able to even buy these. You're gonna have to put a heat pump water heater in your basement.
Wow.
So that's what we're talking about today.
So that's what I see over here, right?
Exactly, this is a conventional hybrid or heat pump water heater. They're called air source because they take warm air from the room, they harvest the energy through the compressor or the heat pump unit on top, they take the warm energy out of that air and then they blow cold air out.
So these units can operate where on the efficiency scale?
The nameplate efficiencies are extremely high for some of these units. They're like 4, but that's in a test condition. You know, in real world conditions, it'll be between 2 and 3, depending on how cold the basement is and stuff like that.
Got it. So if we're in a hot climate, very warm, where you have air conditioning demands pretty much year round, this is a great solution, right?
It's a phenomenal solution. In the South, for example, there's a lot of water heaters in garages, so some air conditioning and dehumidification in your otherwise hot and humid garage is a good thing.
Right.
Up here in the Northeast, where where there's space heating, you have to heat your home. It's not necessarily a good thing.
Right. Yeah. All right. So what other options do we have in a cold climate like this?
So this is a split system, far less known, right? Far less understood. But basically, instead of harvesting warm air from inside, there's an evaporator panel that gets mounted on the wall anywhere in the house, and it harvests the heat from outside, right?
So that panel right there reminds you of a solar panel.
Exactly.
And so you're mounting that outside.
Yeah.
And that is like the outdoor heat pump. That's the evaporator panel, effectively, for a heat pump.
Exactly. So there's no effect on the conditioned space inside. It's not blowing cold air. You don't have to reheat anything. And it looks like a solar panel, but what's happening is that the refrigerant, all these units use refrigerant, the refrigerant is going through the evaporator, and it's evaporating and gaining energy and going back inside to the heat pump unit, which has a compressor, which ultimately makes the hot water.
So the usual common question I get is, so if it's 32 degrees outside or even colder, how does that thing work?
Exactly. So the efficiency of this is extremely high in the summer. In the winter, the efficiency is less. But all that means is that the heat pump unit itself, the compressor, runs longer. So lower COP in the winter, but still vastly higher than a regular electric water heater.
Sure.
But on an annual basis, it'll be between 2 and 3 in the high 2s. Higher in the summer, lower in the winter.
Got it. So you increase the net COP compared to that.
Yes.
And you're way higher efficiency compared to that.
Exactly.
So in a cold climate like this, the fact that I don't have to have discharging cold air and putting that onus on the heating system, the fact that I can do that with an outdoor heat pump effectively with that panel, that really gives us that boost, and especially if the sun is shining on it.
That's right. So this thing is smart enough to know that when the sun is shining on it, oftentimes that panel doesn't see a lot of sun. Sometimes it doesn't see any sun. It's designed to work by convection, which means air movement. If it happens to get some sun on it, then it's happier. But the test conditions assume that there's no sun and there's no air movement. So it's meant to go on the back of a house and the landscaping and stuff like that.
Okay. Yeah. So JC, the question comes down to which option? What are you thinking about here for an upgrade?
Well, this definitely sounds like a great option, so let's do it. Let's install this.
All right, let's get to work. All right, Bruce, we'll help you out.
Thank you, Bruce.
Yeah.
First thing we do is we go in the basement, we figure out where we place the new heat pump on the wall, so we measure from the floor, we mark the holes. We hammer drill. We put a level on it because our heat pump needs to be level. And then a two-person operation, we hang the heat pump onto the bracket. And then we maneuver the storage tank next to the heat pump so we're not wasting space. Electrical, first thing you want to do is make sure that connections are safe. So that means that after you turn the breaker off, and then we mount a new junction box. The tank is in a different location, so we have to extend the conductors to the new location. From that junction box, we'll mount a new MC cable. From the junction box to the tank, we screw the covers back on the tank and the 4 square junction box, and then we test the circuit. Next step, they remove the old tank, they shut the water off, they drain the existing tanks, they cut some piping, they removed the old tank, they wheeled it away, then they measured and cut and made connections to the new tank, pro press connections to the tank. On the refrigeration side, we're going to run the new line set through an exterior wall penetration. We connect our line set to the heat pump, then to the evaporator panel outside. We test with nitrogen for leaks, and we perform a refrigeration triple vacuum to get all the non-condensables and moisture out of the system and make sure that the system runs as cool as possible and as efficient as possible.
All right, the system is on, the tank is filled with cold water, the heat pump is operational. We're in business, right?
Exactly. So this panel, Louis screwed it to the wall. It's got nice stainless steel screws. It only weighs about 10 pounds. Our line set goes through this nice line hide, and then our heat pump is about 6 feet away on the wall here, so it has a nice short line set length.
Nice. So panel is made of aluminum, powder coated, and no moving parts out here.
Exactly. It can't rust. It can't do anything. It'll last indefinitely.
Nice.
And Bruce, I see frost on the panel. Is that normal?
Yeah, it is normal, and it makes us happy because that means that the refrigerant is coming out at relatively low pressure, and it's very cold. It's cold enough such that the moisture in the air is condensing on it and freezing. That means it's doing its job. There's no defrost cycle. This will run until it's 20 below Fahrenheit.
That's amazing.
I also brought an infrared camera. So on this infrared camera here, and you can see that panel is averaging around 20 degrees. So all the hot, humid air, that 50-degree air that we see is actually condensing and creating frost on that surface. So that means it's actually working.
Exactly. Phase change is good.
Bruce, as far as efficiency, what will JC save compared to his old electric water heater?
So it's about a third, right? The coefficient of performance or efficiency of these systems is about 3. Your electric water heater is about 1.
That's great.
That's cool. And installation cost-wise, how does this compare if he went with the centralized, traditional heat pump water heater?
Yeah. So our company installs both. We install the conventional unitary heat pump water heaters, and we install these, of course. We think everybody should have a heat pump water heater, but at the 80-gallon size, this is actually slightly less for us. And in most cases in Massachusetts, it makes more sense.
Well, Bruce, this is great. Thank you so much for your help today.
Thank you.
That was awesome. JC,
Thank
happy
you,
with
Ross.
everything?
Yes, I am.
Awesome. Great.
Thank you, Bruce.
Thank you, JC.
All right. Until next time. Cool.
Yep.
We'll see you.
Thanks for watching. This Old House has got a video for just about every home improvement project, so be sure to check out the others. And if you like what you see, click on the subscribe button to make sure that you get our newest videos right in your feed.